Hey guys, welcome to the LearnAP live stream for Calc. So submit your questions in the chat pertaining to Calc, and that can be A, B, or BC. And while my software loads, I shall answer your questions if you have them. So yeah, if you have any questions, just put them in the chat and I'll answer them right here. Alright, so seeing that there's no questions as of yet, I can sort of get into what we've been talking about in this week's videos. I apologize. Sort of as the stream starts, it's a little slow, but it'll pick up in a second. So in this week's live stream, we talked about, we went over advanced topics of derivatives part 2. So we went over, okay, so you're asking to go over derivative speak. Sure, I'll go over derivative speak for you. And let me snap back to my old document here. Okay, so derivative speak. Now, the concept of derivative speak is sort of, if you remember, let's say we had f of x equals x squared. We wanted to find our relative max and min. We'd find our first derivative, set it equal to 0, solve for x, and then do the first derivative test, where we have x equals 0, negative 1, 1, so just any number less than 0, greater than 0, and f prime of x. So here, plugging these in, I get this, so I can say that this is a relative min by the first derivative test. Derivative speak is basically you're just telling the AP graders what you did. So the first step is to say that you have a critical value. So you say, and you have to say this stuff using math. So say since f prime of x, f prime of 0 equals 0, 0 is a critical value. So you're basically just walking through the first derivative test for the AP graders to say that something is a relative min or max. So 0 is a critical value. And then after that, we can say since, and then you have to walk through this step, which is the actual first derivative test. So since f prime of whatever number you plugged in, here it's negative 1, is less than 0, and f prime of 1 is greater than 0, again, that's just whatever we plugged in here for x, is greater than 0, the point, and then we want the actual point. Here it's just 0, 0, plug in 0 for x to get f of x. Point 0, 0 is a relative min. So we're saying our derivative is 0, so it's a critical value. And since to the left we're decreasing, and to the right we're increasing, this point is a relative min. So that's sort of derivative speak and why you do it. It's for the AP test. If you do this, you know right away that that point is relative min, relative max, neither, but you have to sort of line this out for the graders on the AP test. Alright, and so the next sort of comment is talking about series. We're going to get to series later. One thing I would say for you specifically is that we're looking at finishing our series around late October, mid-November. So it's not going to be sort of we finish a week before the AP test. You know, you'll have a time where we sort of have everything and the AP test isn't for a couple months. Now, that being said, if you have a question about series or conditional convergence or something, even though I don't have a video on that, you can sort of ask away and I'll help you out on that. And to Richard, you're quite welcome. Glad I could help. Alright, so I'm just going to sort of yak about what we did in our last video. But if you have if you have questions, feel free to stop me at any point. Yeah, no problem. Glad that we can help you out. So we first went over the mean value theorem, and this is sort of obvious, saying that at some point on an interval, if we have a function and our average slope, at some point on that, let me sort of say that again. If we have an average, if we're on an interval a to b, and our average slope is, let's say, d, at some point, our slope at a point is going to equal our average slope. And so this is what the mean value theorem says. Now, what's important to note about the mean value theorem is that we have to be differentiable and defined. So a lot of times on the AP test, I'll tell you a function is defined, but they won't say it's differentiable. Which of the following are true? And so if you forgot that and you said, well, the mean value theorem is true, you would be wrong. So sort of a lot of these theorems are really obvious when you say them, but it's important to know when they apply. So for the mean value theorem, our function has to be defined and it has to be differentiable. And sort of remembering back to earlier videos, if we are differentiable, we are continuous. But do note that we can't say that we are continuous, therefore differentiable. So this does not work. But do note that if we're differentiable, we're continuous. If we're continuous, we might be differentiable, but not necessarily. Okay, so again, feel free to stop me at any point if you have questions. We also went over L'Hopital's rule. L'Hopital's rule is basically just showing us how to evaluate indeterminate limits. You might remember in an earlier video, this one, we talked about solving limits without L'Hopital's rule. And I gave you 4 main methods. Direct substitution, or that's not really a method, but it's always something you should do. Factoring, conjugation, finding the LCD. Those are sort of harder, but L'Hopital's rule makes it much easier. So if we have 0 over 0 and our function and our limit is f of x over g of x, then this limit is going to be equal to the derivative of the top and bottom. Just went over some sort of general guidelines for L'Hopital's rule. Both f of x and g of x must be differentiable at c. And we can only use it if our indeterminate forms are 0 over 0 or infinity over infinity. And other ones like these, you're going to have to convert to this. And if you're sort of curious, how would I make 1 to the infinity 0 over 0? Go ahead and watch that video. You can also check out our practice problem solution, where we had an indeterminate form 1 to the infinity, which I then converted to 0 over 0 and did L'Hopital's rule. So yeah, example. And then here I talked about recognizing limits as the limit definition of a derivative. So this right here, if I sort of erase what I had written in the video, this right here is just the limit definition of dy dx for y equals e to the 5x. at 2. Okay, I see we have a question, so I'll sort of jump to that real quick. And we'll switch pen color. Okay, so your question is prove lim x goes to infinity of 1 plus 1 over x to the x is equal to e. So we actually did this in the practice problem solution if you want to check that out. But since you're here, we don't have any other questions. I will walk you through that right here. I don't know, maybe you checked it out, maybe that sort of confused you. Okay, so first, we always do direct substitution first. So our first method, direct substitution. If we plug in, we get 1 plus 1 over infinity to the infinity, which is 1 to the infinity. Now note that this is not equal to 1. You might be thinking, well, it's just 1 times itself over and over again. But it turns out that's not the case, and without jumping into grad school level mathematics or something like that, I can just be assured that 1 to the infinity doesn't necessarily equal 1, and why that is. For the purposes of AP Calculus, you can just sort of not worry about it. Alright, so 1 to the infinity, indeterminate. Alright, so we need to get this into a form of 0 over 0. So what you can do when you have 1 to the infinity or 0 to the 0, or where you have an indeterminate form with exponents, is you say y equals your limit, and then you're going to take the ln of your limit, so the natural log. And remember log rules, this becomes x times ln 1 plus 1 over x. Okay, so if I just give myself some more space here, I'm sorry, this should be the limit as x goes to infinity of x times ln of 1 plus 1 over x. Okay. So, yeah, remember to keep your limit there when taking the ln. Alright. You don't necessarily have to keep writing out ln of y, but as we get further along, I'll show you why I sort of think that's an important thing to do. So let's plug this in. And so this is going to give us infinity times the ln of 1. Now, quick side note, ln of 1, let's say equals x, e to the x equals 1, I'm sorry, ln of 1 equals x, e to the x equals 1, x equals 0. So, thus we're going to end up with something sort of weird. Infinity times 0. What is that? So here, the method to do is 1 over 1 over x. So I'm going to actually rewrite this again as the limit as x goes to infinity of 1 over 1 over x. And since I'm just going to multiply this ln on the top, And now we can see that we have 0 over 0. So now we can do L'Hopital's rule. That's sort of an easy step to get stuck at, where you have infinity times 0, which is, again is another indeterminate form, but you can actually do L'Hopital's rule. And so to this, remember that let's say I have a fraction 1/4. This is equal to that's sort of a bad example. If I have 4, this is equal to 1 over 1 over 4, which is saying 1/4 inverse. Would this be a question that I would have to write out on the AP exam? Absolutely. This is sort of a more complicated limit problem, and while I doubt they'd give you the limit definition of E, like the specific problem, you should be ready for limit questions where you're getting like 1 over infinity or 0 to the 0 type thing. So you should definitely be familiar with how to sort of tackle this type of problem. So again, jumping from here to here, keeping in mind that 4 is equal to 1 over 1 over 4, that's how I'm writing this x as 1 over 1 over x, and that's turning infinity times 0 to 0 over 0. So now I can do L'Hopital's rule. ln of y equals limit as x goes to infinity of minus, remember we take the derivative of the top and bottom separate, so minus 1 over x squared, that's the derivative of 1 over x. Derivative of ln is just u prime, which is the derivative of ln of u is u prime over u. The derivative of our inside here is minus 1 over x squared, all over 1 plus 1 over x. These are going to cancel, and we're just going to evaluate this, which is going to give us 1. And now I sort of told you that you didn't have to keep writing ln of y, but that I really recommend it, and that's because of this. We've solved our limit and we've gotten 1, but remember that the limit definition is saying that this is equal to e. So are we wrong? Did we get the wrong answer? Well, it turns out that this ln of y is important, because 1 is equal to the ln of y, not y. So ln y equals 1. If I solve for y, remember this is just log base e, so y equals e. And that answers your question as far as the limit definition of e goes. So yeah, common pitfalls to make on that problem were sort of not figuring out how to go from 1 to the infinity to 0 over 0. First way is not knowing how to do this ln of y thing. So when you have exponents that are giving you indeterminate, you want to say y equals and take the ln. You're welcome. And then sort of converting this to this. And then at the very end of the problem, forgetting that this 1 was equal to the ln of y and not equal to y. So good question. Again, if you guys have more questions, be sure to ask away. But doesn't look like we have any more, so I'll just sort of yak more about what we did in our last videos. So recognizing limits as a derivative. And so if you recognize this limit as equaling this, well, I can just take dy dx. and find out that this is equal to I'm sorry, 5e to the 25th. 5e to the, yeah, okay. Okay. So that was that video. And then this stuff, important note, BC only. Alright, so as I sort of go over this, this video was for BC only. And I talked about parametric derivatives and polar derivatives. And they're sort of, they look sort of tough on paper to find dy dx for a polar or parametric equations. But actually, the majority of your work isn't going to be in conceptual things because it's very straightforward, dy dt over dx dt. A lot of times your challenge is going to be finding dy dt or dx dt, and also simplifying. So a lot of times these can get sort of big, and you'll be asked to simplify it, and that can be sort of very overwhelming sometimes. And I didn't go over that much in the video just because that's more sort of algebra to know, and you know, I'm here to teach you BC concepts, but you know, if you have questions on how you would simplify something, I can answer that, of course. Alright, and then again, this, for anyone just tuning in, BC only. Next I talked about finding a polar derivative. And so dr d theta is pretty straightforward. We're taking derivatives like we normally would. So here r equals 3 sine theta just becomes dr d theta equals 3 cosine theta. We're just taking a normal derivative. Now sometimes you'll be asked to find dy dx, and if you didn't know this right here, or how you would get that, you might sort of be confused and think, you know, do I have to convert this to Cartesian and then differentiate implicitly and then convert everything back? And the answer is no, you don't. You just have to find dy d theta over dx d theta. And so, to get dy d theta, we need to get y equals some function of theta and x equals some function of theta. And the way to do that is to get your equation. See here we have r equals 2 plus sine theta. We need to get this to say r sine theta equals and r cosine theta equals, which is just another way of saying x equals and y equals. Take our derivative, and that would give us dy d theta and dx d theta. Alright, that does it for that video. Feel free to stop me at any point if you guys have questions. Yeah, so just in general, anytime we upload a BC video, we'll upload one for both AB and BC afterwards, or on the same day. Okay, so this video went over critical points in relative extrema and the first derivative test. So if you're sort of confused as to what a critical point is, we're saying that this is where f prime of x equals 0 or undefined. And the way to think about this is, if at some point our tangent line is, the slope of our tangent line is 0, we have a relative min or max, and that's why we try to find critical points. But critical points aren't very useful because, are we at a relative min? I'm sorry, at a relative max? Or are we at a relative min? They tell us what our slope is, but it's not telling us much about what the function does outside of it. And so that's where the first derivative test comes in. The basis of the first derivative test is we're sort of seeing what is the function doing to the right, what is it doing to the left of our critical value, and from that we can say sort of what it is, whether it's a relative min or a relative max. And so one thing that you might be confusing is, let's say we have a CV here and we're doing this. Do I have to memorize that to the left if it's increasing to the left and decreasing to the right, that is in fact a relative min? And the answer is no. And what you can do is you can just say increasing to the left, draw a increasing line, an increasing line, decreasing to the right, draw a decreasing line, and that's a relative max. Conversely, if I had this, I can just draw CV to the left, I'm decreasing, to the right, I'm increasing, relative min. Okay, and similarly, something like this, decreasing to the left, decreasing to the right, nothing. Okay, so that's sort of a good way of thinking about that. Then I talked about speaking derivative, which I went over earlier in the live stream. But again, feel free to stop me at any point if you guys have questions. And then sort of something similar is finding absolute max and absolute min. And so a relative min is not an absolute min. So let's take this function. Actually, hold on. Let me get my coordinate axes, make this a little more clear. Okay. So for this function, and I will change color as well. Alright, so let's say we have a function like this, f of x. This right here is a relative min, or somewhere around there. Here we have a relative max, and that word relative is important. What that's saying is to the left of this and to the right, like just to the right and just to the left, the values of the function are greater than this. So again, it's sort of going from decreasing to increasing. That's what relative means. But if we think about it, neither of these are absolute maxes or absolute mins. This function is going up and its value is greater than that at the relative max. Similarly, here on the left, it's going down and is less than that of the relative min. And so that sort of brings me to my absolute max and absolute min. In problems like these, you're asked to find the absolute max, the max on an interval. What is the greatest value the function achieves on the interval? And it's also important to note that it could be. So let's say we have an interval a to b. Here's well, okay, I'll draw it like so. Okay, so this is our function, and we want to find the absolute max and absolute min just from looking at this. Well, here we have a relative max, but we also have an absolute max. Here we have a relative max, but it's just that, a relative max. Here we have a relative min, and here we have an absolute min. So what I'm trying to get at from this is that relative maxes can be absolute maxes. Absolute maxes can be relative maxes, but not necessarily. None of these things are inclusive. So if we want to actually find our absolute max and absolute min, we have to get our critical values on the interval. So let's say f of x equals x cubed on the interval -3 to 3. So here we need to first get our critical values in the interval, and you should all be familiar with this. Don't need plus or minus because, you know, there's no plus or minus 0, but common mistake to make. In addition to that, so now we need to sort of plug in our critical values. F of 0 equals 0. And then since I said that our endpoints can be absolute maxes and absolute mins, we need to plug those in. So this is equal to -27, and this is equal to 27. And okay, looking at this, we can see that -3 is our absolute min, and 27 is our absolute max. So yeah, if you're asked about absolute max and absolute min, you need to get the critical values on the interval and check those in the function, not in the derivative. But you also need to check the endpoints. So very important there. Example problem, challenge problem. Okay. So if you guys have any questions on that or anything else, you know, feel free to submit your questions in the chat. Otherwise, I can sort of just go over some other stuff for now. Get some more space here. Okay. So let's say that we have, let's say we have y of t equals 3t squared plus 5t sine t, and x of t equals square root of t. What write the equation of the tangent line at what do I want to do? We'll say x equals 0, and this one I'll take away the sign because that would get really complicated. 0, or no, I'll say 1, 8. Okay, so here, well, one thing we need to do is we need to find dy dx. and then I can plug this into point slope form and get our equation. Alright, so let's do that. Let's find dy dx at 1, 8. Get some more space here. Alright, so y prime of t equals 6t plus 5. X prime of t equals 1 over 2 root t. And this is just the power rule. Remember that this is equal to t to the 1/2. And that thus this would be t to the negative 1/2. Alright, so I see a question from Sam, who's asking, can we make a video covering related rates and implicit differentiation? Well, it is just your lucky day, Sam, because on Thursday we're going to have a video coming out on related rates. Go over some related rates problems, and then I also give you a challenge problem where the solution will be on our website. In terms of implicit so again, that video comes out on Thursday. So yes, we will be having a video on related rates. Implicit differentiation, let me make sure I got this right, but I believe we went over that in, yes, okay. In Advanced Topics of Derivatives, Part 1, we go over implicit differentiation. So check out that video. And then, even though we haven't gone over related rates, I'd be happy to help you with a related rates problem if you had a question. So again, Advanced Topics of Derivatives Part 1 for implicit, and then we'll have a video coming out Thursday on related rates. Okay, so anyway, but you know, I'm just doing this example. If you have a question on that, be sure to ask. So here to find our dy dx, we're putting y prime of t over x prime of t. So 6t plus 5. And then this is just leave change flip. So 6t plus 5 times 2 root t. Alright, and so now let's find dy dx at 1, 8. Well, we sort of have a problem here. This coordinate here is x equals 1, y equals 8. And dy dx here is in terms of t. So what do? Do we convert this to Cartesian? And the answer is no. What we want to do is we want to find, well, at 1, 8, what does t equal? And for this, you can plug in either 1 into x of t, or you can plug in 8 to, I realize I wrote that wrong. This should be 8, 1. Oh, no, that's right, sorry. 1, 8. Do I plug in 1 to, or do I solve for 1? You don't plug in 1. That's what I was getting confused in. Do you want to solve for 1 for x of t, or solve for 8 for y of t? And here it's probably easier for x of t. So 1 equals root t, t equals 1. And just to show you, we'll get the same thing if I do it for y of t. So here we've gotten that t equals 1. Alright, so I've gotten that t equals 1, so I can now plug that into our derivative. equals 11 times 2, 22. And so now I just need to write my equation for the tangent line. Okay, and this is our equation. Now, I sort of blew through that, so you might be wondering, well, how did I get this? And this is from something that's extremely useful in AP Calculus. And this is point-slope form. So you might be used to something else called Slope-Intercept Form. And this is y equals mx plus b. Well, point-slope form is this same equation, but it's written a little differently. Y minus y naught, or just some y coordinate, times equals mx minus x naught. And y naught, and x naught are just any xy coordinate on our function. And so here, x naught is 1, so I just plug that in. Y naught is 8, plug that one in. And our m we got from dy dx, 22, plug that in. And so this right here is our answer. Alright, so that does it for that question. If you guys have any more, again, even if it's on something we haven't covered in the videos, more than happy to help you guys with some stuff. Okay. Alright, I'll go over a little more point-slope form. Let's say we have y equals 3x plus 1. And I have the point 3, 10. I could also write this as so, and just to sort of prove to you that these, like so, in point-slope form. So here is slope-intercept, and this is point-slope. And if I solve this one, oh wait, I wrote that wrong. Okay, yeah, I was like, what? Now if I solve this, I can see that they're the same. So that's where point-slope form comes from. Alright, so again, if you've got questions, sort of entering the last 15 minutes of the live stream, so maybe you have some questions, I can help answer those. Alright, so we can also go over some other stuff relating to what we've done in the videos so far. Let's say that we have the function y equals sine cubed x. Actually, let me write this out in a different color so it's a little more clear. So we have y equals sine cubed x. Find all relative extrema on the interval 0 to pi. Whoops, okay, this should be. I don't know that you would ever see a problem like this. I highly doubt you would ever see that if you were curious. I didn't. I wouldn't worry about it. Okay. So this is not too confused with an absolute max or min. This is asking for relative extrema on this interval, and you would see this with sine and cosine because if you think about sine, this has an infinite amount of max and min. You can describe them by adding pi n or 2 pi n or something, but sine and cosine is sort of the classic relative extrema on an interval. So first we want to find dy dx and set that equal to 0. Alright, and here I'm doing the chain rule. So again, this is sine of x cubed, so 3 times sine of x squared times the derivative of the inside, which is cosine. So that's how I got that. Alright, now solve for 0. Alright, so this is already factored, so I can say the following. If any one of these equals 0, my function is going to equal 0. I'm sorry, I sort of jumped ahead. Alright, so first I want to set my derivative equal to 0. Alright, and now solve for x. And so here I can say that if any one of these equals 0, my function is going to equal 0. So just split it up by the factors. And this is what you do in factoring. 3 equals 0, that's extraneous. Sine squared x equals 0. Cosine x equals 0. Alright, so we want to think about where does sine equal 0 on the interval of 0 to pi? Well, at pi over 2. It also does at 3 pi over 2, but that is not on our interval. Where does cosine equal 0 on our interval? I'm sorry, that's cosine. Sine equals 0 at x equals 0 and pi. And cosine equals 0 at pi over 2. Because remember, cosine is x, so at 0, 1, cosine is x. And I sort of went over this in the unit circle video. That's our third video in the LearnAP Calc playlist. If you're struggling to sort of learn the unit circle, I would definitely recommend watching that video. Alright, so now we have our critical values. So now we want to do the first derivative test. Alright, so we'll say -1. This is x equals, this is f prime of x equals. Alright, so we want to pick easy values, so negative 1, yeah, okay, that's easy enough. Between 0 and pi over 2, pi over 4 is pretty easy. Between pi over 2 and 3 pi over 4 is easy. And after pi, 2 pi is pretty easy. Okay, So what is f prime of negative 1? Well, we want to take the sine of negative 1. So we remember that sine is y. So at x equals negative 1, well, wait, no, that would be the arc sine. I'm sorry, that's actually pretty hard. We'll do negative 2 pi, which is basically 0. In terms of angles, it's 0. So the sine of negative 2 pi is equal to the sine of 0. Or no, wait, I can't do that because that's going to give me, that would give me 0. I can't do that. So negative pi over 4. When you're dealing with a question like this and you pick something outside the bounds, you might be picking a different relative extrema, and if that's giving you 0, you're messing up. Because basically what you're doing is, say, you want to find all relative extrema on this interval, and then you choose this point, or maybe this point. That's going to mess with things. So that's what I was doing. Something to keep in mind. Alright, so the sine of negative pi over 4 is going to be equal to 7 pi over 4. Alright, so this is 3 square root of 2 over 2 squared times square root of 2 over 2. And I don't need to actually do that to just know that that's positive. Sine of pi over 4, this is going to be sort of the same thing. That's positive. 3 pi over 4. Our sine is going to be positive, but our cosine is going to be negative. And so this is going to be less than 0. And again, 2 pi is a bad value to pick, so I'll just do 5 pi over 4. Alright, and so plugging that in, we can see that this is negative. So our only real critical value is here. Because here we're going from decreasing to decreasing at pi. Or that would be increasing to increasing. But you can see that pi over 2 is our only real relative extrema. So at that point, we need to now write out this in derivative speak. Since f prime pi over 2 equals 0, x equals pi over 2, x over pi over 2 is a critical value. Since f prime of pi over 4 is less than 0, I'm sorry, is greater than 0, and f prime of 3 pi over 4 is greater than 0, or less than 0, I'm sorry. I'm kind of tired. Probably won't get better tomorrow, Monday morning. Anyway, since the derivative at pi over 4 is greater than 0, and our derivative at 3 pi over 4 is greater than 0, the point, alright, pi over 2, and then we need to get our y-coordinate. So the sine of pi over 2 is 1 cubed which is 1, point pi over 2 comma 1 is a, alright, let's think about it. So if this is pi over 2, from the left we're increasing, and from the right we're decreasing, so is a relative max. Alright, so that's how you would do that problem. We're sort of in the last 4 or 5 minutes or so, I'm going to refrain from doing any more example problems. If you guys have any more questions, whether that's relating to the channel or content or where to find a video, or you know, I could probably squeeze in another question if you guys have any. But yeah, if you have anything relating to content, maybe the website or something, you can ask. But in case you guys were not aware, alright, in case you guys weren't aware, this isn't the only sort of resource for LearnAP. We also have a website, LearnAP.com. So you can also check us out there. We've got some articles up. We've got some practice solutions and stuff that you can work on. So I'd definitely check our website out. We also have a Facebook page where we're just LearnAP. And we also have a Twitter at LearnAP. Alright, and so if you follow us on either of these, or like us on Facebook, or follow us on Twitter, you can be reminded for our live streams. If you also don't want to miss a live stream, you can email us, info@learnap.com, and we'll send you an email right before the live stream so you guys don't forget. If you enjoyed this video, please like and be sure to subscribe for future content if you haven't already. It doesn't look like we have any more questions, so I'll sort of give you guys a second if you have any to ask. But it looks like we don't have any more questions, so I want to thank you guys for tuning into this live stream. We'll be back a week from today, same time, 4 to 5 p.m. Eastern. We'll answer your questions about calc. And other than that, I want to thank you guys for checking this live stream out, and I will see you next time.